So let's get into price risk. Probably the most talked about in finance is price risk. So our definition of price risk is quite straightforward. An asset value falls or a liability value rises such that you lose money. So we're not going to do interest rate risk, but it's a special case of price risk related specifically mainly to bonds. How do we measure it? Well, there's a few ways. We've already learned one with beta, so you should be pretty comfortable with beta. You've done the Excel exercises with beta. Beta measures systematic risk. Standard deviation you should have had in your finance, in your stats class. And we're going to do value at risk, and we're specifically going to do parametric value at risk. Before we do that, let's just remember what is standard deviation. So for standard deviation, you have two sets of data. Let's say X and Y. Oh no, you don't. You only have one set of data. Excuse me. One set of data, X. And so to get the standard deviation, you take X sub I minus X bar. So if you remember, X sub I is each individual piece of data. So if you have monthly data back 10 years, you have 120 pieces of data. Maybe it's the return on the stock market, maybe it's the temperatures in San Antonio, whatever. But each month, so you have the first month 10 years ago, the second month, third month. You take each one of those months and you subtract the average. That's what X bar means. I can't actually do the X bar like they did in stats, but X with the bar over it, which means the average. So you take each individual thing minus the average, and then you square that. And what's important there if you square it, squaring does two things. First of all, negatives go away. So if xi is 10 and the average is 12, 10 minus 12 is negative 2, but you square it, you get 4. So negative values go away. So what we mean in this measure of risk is the distance from the average, not just the downside. So if we're doing returns, if you made 1% in a month and the average was 0.5%, then that gives you a positive number. If the next month you're down 5%, 5 minus 0.5 gives you negative 5.5. You square that, you still get a positive number. But if you get 10 minus 0.5, you square that, you get a big number. So what we're looking at, negatives go away. We're only interested in how far can you get from the average. If you have something that gets really far from the average, it's going to give you a really big number because you're going to square it. If you get something that rarely gets above its average, then you're taking a small number and squaring it. You're not going to get much of a number. The second thing you see is that outliers get exaggerated. I don't know how to. I never know how to spell outliers. So numbers that are really far, because we're squaring it, it makes them really, really large. Because of that squaring function, outliers get exaggerated. So we just in the last few weeks have seen some amazing moves in the stock market. Large moves that we've really never seen before. Really, some of them not even since the Great Depression. Some of them more volatile than what we even saw in 2008. Well, because if that data goes into your data set, it's going to have a sudden huge impact on your standard deviation because they're such outliers. They're so big in your squaring. So that's what squaring does. All right, so you take the differences in the mean and you square them, and you take all of that and you take the average. So you're essentially, this is volatility. Volatility is the difference of each point minus its average squared divided by the number of points that you have. So and then last thing we'll do is we'll take the square root of that. Oops, I don't want to. Okay, we'll take the square root of that. So the square root of all of this is standard deviation, and in Excel, STDEVP is that function. Now, hopefully you remember from your stats class, if you take the P out, the P stands for population. If it's just STDEV, then you don't divide by N. Hopefully some of y'all remember you divide by N minus 1. You remember the concept of degrees of freedom. So STDEV is N minus 1. Most of the time in your finance exercises, you'll use STDEVP. You won't use STDEV. So there's really important here that standard deviation is not looking at how many times you're below average or how far you're below average. Standard deviation says how far are you from the average. The assumption is if you can be way above the average, then in the future you could end up being way below the average. So that volatility above the average gives you some indication that some volatility you could have below the average. So we don't care if we're just above or below. There is a measure of risk. It's called semivariance, which only looks at the standard. Essentially, it's the standard deviation only when you're below average. We're not using that calculation. We're going to be using standard deviation. All right. So hopefully you remember that. If you are a finance or accounting major, probably a marketing major too, you should have this formula. Just know it. Don't need to look it up. It's not a very difficult formula, but just know this formula. Hopefully you learned it in stats and remember it backwards and forwards. We already talked about beta. Beta looks very similar to standard deviation, except for beta you do have to have two pieces of data. You do have to have the stock and the market's return. We're going to be doing value at risk, and we're doing parametric. Parametric value at risk uses standard deviation as its input. Historical and stochastic value at risk, what they do is they look at several scenarios. Stochastic you can think of as Monte Carlo. So you might run 100 scenarios, 200 scenarios, and you're going to calculate your value at risk looking at those scenarios. Historical, you're also using scenarios, except for your scenarios, your actual historical data that you're pulling up from the past. So we won't use historical and stochastic. I do cover those in my risk management class, and we do some exercises there. Not too much because we don't have a true stochastic model I can use at UTSA, but we do look at historical, and we do at least do some exercises with stochastic without actually running the numbers themselves. All right, so value risk is what we want to do. I encourage you to pull up the annual report of JP Morgan or Goldman Sachs and look for value at risk. It's abbreviated V, capital B, small a, capital R, VAR, VAR. And a lot of times in finance, you won't hear them say, what is your value at risk? They'll say, what is your VAR? All right, so there's our measurement. And I'll show you the formula. The short formula is real simple. Trust me, a very simple formula. And then we mitigate risk on price risk mainly through diversification. We're not going to be able to do diversification here. I do it in my risk management class, and we talk about it in my investment class. But here we won't be using diversification or correlation to mitigate price risk. What we will do is use risk budgets, or risk limit. Risk budget, risk limit tells you how much risk you can take. Value at risk tells you how much risk you are taking. So this is a measure of your frequency and severity, and this is the measure of how much risk you're willing to take. So if your VAR is greater than your risk budget, you're taking too much risk, and you need to pull back somewhere and take less risk. So the measurement is how much we expect it loses some probability. That's called value at risk. Our mitigation is how much we are allowed to lose. That's our risk budget or our risk limits. You'll see both ways. If you went into JP Morgan's annual report, the word limits would be there all over the place. I don't think JP Morgan uses the term risk budgets. Risk budget was a term that was really popular about a decade or so ago, but risk limits has taken over as the term that most people use. These formulas, I'm tempted to do this. If we have time at the end of the semester, I'll show you this. These formulas, standard deviation, beta, correlation, R squared, are 4 formulas you should know off the top of your head. You shouldn't have to look those up if you're a business major. But the nice thing is the formulas are almost all identical. So once you learn one, the others are easy to remember. They're very, very, very similar. They all involve taking a difference from the mean, just like we did for standard deviation, with standard deviation, we squared. With beta correlation R squared, because you have two items, you actually multiply those differences by each other. So if you have x and y, you take x1 minus x bar, and then you take y1 minus y bar, then you just multiply those two things together. Then you divide, and here you actually divide by n, so you're getting essentially the average. You do that just like we did with standard deviation. I don't know what it says, add. Add's not a good one to put there at the end. And then they're all different. Standard deviation, you take the square root. With correlation, you divide by the standard deviation of x times the standard deviation of y. For beta, you take all of that and you divide by the standard deviation of y squared. R squared is just a correlation square. But if we have time in this semester, I'll show you that. I do it in my risk management class, and I think I do this in my investment class. It's a really good exercise. If you want to understand how to do this, email me and I'll point you to the place I did it in the class. I think I may not have videoed that, but I can show you how you should do it. One of these times I'll create a video on that, because you really, I know some of you non-finance majors are thinking, I don't need to know this, but everybody needs to know this. I think I got a few promotions at UTSA simply because I knew these formulas off the top of my head. So here's the discussion here, but we won't do this in this class unless we have time at the end of the semester. We'll come back. All right, so here's the formula. This is the important part. This is what we're going to use. Value risk equals the mean, that's the average. I'll give you the average, minus the number of standard deviations. That's a number we're going to pull from the table, times the standard deviation. The standard deviation is given. So I give you the mean, I give you the standard deviation. I don't give you the number of standard deviations, I give you the probability. The probability I give you will equate to some number of standard deviations. Now you probably have seen some of these before. If remember in stats when you did a 99% or 1% test, that was 2.33 standard deviations from the mean. 5% was 1.64 or 1.65. I don't like to interpolate, so 95% is right between 1.64 and 1.65. I usually use the higher number. Let me show you this in Excel. Sorry, it's not letting me move here. So if we start a corner at 0 and 0, anytime I have Camtasia on, which is what I'm doing these recordings on, it really slows down my machine. If we take that 0 and we add 0.01, and then we copy that across until we get out to 0.09. Oops. So that plus 0.01, and copy that across out to 0.09. And down here, we don't add 0.01, we add 0.1. And this you can go down as far as you want to. Bill Gates doesn't go much past 8. So we'll just stop. We'll stop at 8.1. So you'll see this in some textbooks. So what we're going to do in Excel is we're going to use the equal norms dist. Norms dist, you do the B and lock in the column. So $B5, comma, and you go up to C and you lock in the row. C $4. And when you do that, it's asking what percentage of the normal distribution is to the right or the left of the mean. And when you hit enter, you'll get 50. That should have worked, but it's not working. I don't know why. 0 and 0. Norms dist. Yeah, for some reason. Oh, I'm sorry. It's not comma. It's norms dist $B5 plus, sorry, C $4. It's not comma. So $B5 plus C$4, and you'll get 50%. We used to go out 4 decimal places. You can copy that down. You can copy that across. And you can copy that down. And this is what we call a normal table. You probably used a normal table in your stats class. So that's what I was talking about, 1.64. Look at that 1.6, and you go over to the 4 column. You can see between 1.64 and 1.65. You can see that's right at the 95%. So inside this table is the percentage of the curve that is to the left of the normal curve. So let me just show you a normal curve. You should have seen this in stats. Remember this. So if I'm 0 standard deviations from the curve, let's look at this one. So if I'm 0, so 0 means I'm right at the average, then 50% to the left, 50% to the right. And so that's why it's 0, 0. 0, 0 means we're right at the average. So 50% to the left, 50% to the right. If we move 1.64 standard deviations to the right or left, then to one side is 5% of the curve, and the other side is 95% of the curve. So if right here is 1.64 standard deviations, right, maybe right here, then 95% would be that way and 5% would be that way, because 100% of the curve, the curve represents 100%. If we go out 2.33 standard deviations, maybe we're right out here, then 99% is to the right, 1% to the left. We're going to be spending our time on the left-hand side, on the loss side. So we're going to think about 1% to the left and 99% to the right. And so what you need to do, so if I tell you that their risk tolerance is 1%, then you're looking for 99% in the table. There's 99% right there. You can see 99% is in the 0.03 column and the 2.3 row, so that means a 1% event is a 2.33 standard deviation event. Some people say a 2.33 sigma event. As you notice, as we get out to like 4 or 5 standard deviations, it goes to 1. And when you get out to 8.9, exactly 1. I mean, you can't, I can't show you here because with Camtasia on some reason it doesn't work. But anyway, that's a normal curve. So I'll show you the formula when we do the problems in Excel. I'll show you the formula. So all you have to do is type in the standard deviation, and it will actually give you these numbers. I'll show you there's a special formula that does that. We'll do that in our next class. So our next class, the first session, we'll be working through, well, we'll probably work through some examples. So I'm gonna for parametric var, we'll work through the process, and then we'll do some examples, and then probably the second or third session of the next class, we'll work the actual Excel applications problems. So let's stop it there, and next class we'll work through the process of parametric var. So something you could do would be to go in to Google and just type in parametric value at risk, hit enter, and then click on images, and you'll see all kind of sites that will come up when doing that. I don't know if Wikipedia has anything on that. We'll see. Here's Wikipedia. They have value at risk, and they'll talk about parametric value at risk in there, and they'll have the same type of normal curves in there as well. So again, this is another area where Wikipedia and Investopedia, you could probably go out and do your own reading and give yourself a little bit of a head start on this class. But it should be a good review for some of the stuff you did in your stats class. So next class, we should be ready to go. We might finish most of risk, at least the pricing risk, next class.